Welcome to the hands-on section. We'll set up a production-grade fleet optimization environment using 100% open source tools. Here's what you need. Number 1, Python 3.9 or higher. At the time of the recording, the highest version of Python that worked was 3.13. Now, this is the core language for our entire stack. Install using conda or from python.org. Number 2, Docker and Docker Compose. This is essential for containerized services, and you can get it at docker.com. Third is Minikube or kind, which stands for Kubernetes in Docker. And this is for local Kubernetes for deployment. Install guides are in minikube.sigs.k8s.io. Number 4, Helm, which is the Kubernetes package manager. And you can get it via helm.sh. And last but certainly not least is Git, which is version control for our collaborative system. We can download it from git-scm.com. Best part, 0 cloud accounts, everything runs locally. Now let's build our infrastructure. Our infrastructure setup is composed of 3 different layers, and we'll deploy them in those 3 layer or phases. First of all, we'll do the data platform deployment. That involves starting MinIO, which is started with this docker run command. You can access it at localhost 9000, which is the default, along with the default credentials. The second part in that data platform deployment is the Kafka cluster. We can basically launch it using the docker compose command. This basically creates the vehicle data streaming backbone. Now, the third component is the timescale.db, which is a Postgres extension. So we install PostgreSQL with this time series extension named timescale.db, which allows it to be optimized for time series telemetry data. Now let's go to the next layer, the processing layer. First, we need to install Spark on Kubernetes, which can be done using this Helm Spark operator, and this basically creates the scalable processing cluster. And the second part is to install the MLflow tracking server, which can be installed using this Docker run container. You can access the experiments at localhost 5000, which is the default port. Now moving on to the third layer, the serving layer. This is composed of 2 different components. First, we have the Seldon core for model serving, which can be installed with Helm and the Seldon core operator. This gives us the Kubernetes native ML deployment. And second, we have the Valhalla routing engine, which is a container that can be installed with the docker run command. So remember, this will give us the OpenStreetMap powered routing API. There you go. The environment is ready in under 10 minutes. Now let's generate some test data. To prepare our data set, we're going to create realistic synthetic data using Python. There are no proprietary APIs needed. This script will get you started basically creating the vehicle telemetry generator. So it includes fields such as the vehicle ID, the timestamp, the engine temperature, the engine RPM, and what have you. The second script that we're going to look at is a data generator for the routes. So this route data simulator will basically generate synthetic delivery routes And the next thing we're going to do, now we have those two data sets, is we're going to load it to timescale.db. This script, including the create statement, will create a hypertable, which is a table optimized for those types of time series telemetry data. And we can insert the data that we generated into that hypertable. Afterwards, we can also stream some of the real-time positions with this script, which is the stream to Kafka script. And now that we've done all that, our pipeline is ready. Now we can test it, and that's it. The one thing I will add is that you can modify and tweak the generator scripts based on your unique circumstances. In the full code in the description, you will see how they all integrate as seed data to get you started on the fleet optimization platform. So in just 15 minutes, we've built what would cost thousands monthly on some cloud services using production grade open source tools. So this isn't just a tutorial, it's the exact stack used by Logistics Unicorn. If this saved you future cloud bills, like this video, it helps others discover open source solutions. Subscribe for the next iteration of optimization deep dives. Comment which tool you are most excited to try. Again, full code in the description. Let's build the future of transportation open and efficient.